Okay, so today I'm going to talk about Raven, which is an internal tool that we use to gather operational insights at Netflix. So first of all, where did I come up with the name Raven? So there's basically two origin stories. On the left, you'll see an actual raven. It turns out that ravens are actually excellent tool users, and you can see that this raven is carrying a stick, and he's poking it for bugs. So just like a real raven is using a tool to look for real bugs, hopefully our software raven helps you as a tool to look for software bugs. So that origin story makes it sound like I put a lot of thought into the name. Unfortunately, it's not the real story of how we came up with the name. We went into a meeting where we were coming up with the name, and one of our developers had just been reminiscing about a relatively obscure show from the 90s called That's So Raven. And we're like, oh yeah, Raven, that's something that sounds like a good name for a tool. And that's how we came up with the name. All right, so before I actually go and talk about the tool, I kind of want to talk a little bit about typical problems that we have at Netflix to sort of kind of set some motivation. So you may have actually heard this joke if you've come to other Netflix talks, but one of the jokes that frequently engineers say at Netflix is that we're a logs company that occasionally streams movies. And what we mean by that is we generate really just a ton of operational data. So if you just think about it, you know, you want to watch Stranger Things on your device, well, we're going to go ahead and get logs from the device saying, oh, you started to play, this was the CDN you used, this is the bit rate you have. And we collect all that information to try to evaluate so that we can get that information and figure out when there are problems. So those client logs are then sent to our edge tier servers, which in turn, they also generate plenty of server-generated logs. So for example, these edge tier servers are calling other servers, and they're generating structured data about durations and error rates and all this other stuff. And you know, finally, that data then flows through both to persistent systems, and more importantly for Raven, it flows through a streaming pipeline where there's a real-time streaming of data. Okay, so let me just kind of talk about, so that's kind of a typical setup. Let's talk about a typical problem that a Netflix developer might need to solve. And this is a real example, that's why I picked it. This is a real example of someone who was trying to debug something using our tooling. So basically, imagine that you have 100 devices. And they could either be test devices in a QA scenario, or they could be real devices in a prod scenario. And 100 of them, but 90 of them work great, and 10 of them don't work. And the first question is, what's in common with the 10 devices that don't work? You know, it could be something like the SDK version, what version of the Netflix device software, what server is hitting it hitting a canary, you know, what CDN is it on, all these types of questions. So how do you isolate what's in common among the 10 servers that are not working, right? And in this real-world example, it turned out to be something called an ASN. The meaning of an ASN isn't actually that important here, but it basically means autonomous system number. It's part of how IP routing. So basically, there was something wrong with some part of an ISP. And once this person had a hunch that said, you know, the data looks like they all have the same ASN in common, the next thing they want to do is grab a real-time stream of the data coming both from the bad ASN and from example good ASNs and compare them to see if they're different. And they looked at some examples of the data, and it looked like they were different latencies, different error rates. And so that was a good hint. And then finally, they're like, OK, well, there's so much data. How do I get a signal out of this? And so what they wanted to do is take examples of the data that's coming in and then plot that data in a way that they could produce a graph comparing the durations on average for the bad ASN and the good ASN. And from that, they were able to really confirm ASN is where the problem is, and they were then able to go work with the ISP to go fix the problem, and then the 10 devices also started working. So, I mean, from that, you can kind of see key needs that we have at Netflix. So the first one is timely streaming data. So let's just talk about that. First, timely. So we really care about data that's happening right now. So, you know, data that's happening 10 minutes right now, in many scenarios, particularly in prod debugging scenarios, may not actually be as valuable as the most recent data. So unlike a lot of streaming systems that really put an emphasis on things like guaranteed delivery of data, We have that option, but we don't really use it that much. We really, I mean, you can just drop data that's older, right? We really want the most recent data. And so it's really a best effort approach to getting the most recent streaming data that's proven the most valuable to us. The second thing is that the data needs to be fine-grained. So as you can imagine, there's an awful lot of data generated by Netflix. So from this enormous fire hose, we need to be able to pluck out the data that we need. So in the previous example, for particular devices and particular ASNs, we want examples just from those. Obviously, we operate at massive scale. And then the other thing that we kind of want, we want a slick user interface for most use cases where you're just kind of working through something on the fly. We also kind of want to provide power user access sort of through programmatic APIs and command line interfaces for other use cases. So the other thing I just want to mention, almost every data element that goes through the logs at Netflix is JSON. That's sort of an underlying assumption. And we care a lot about the top-level keys of these JSON logs. However, just because they're top-level keys doesn't mean they're nice. So you can kind of see here that there's some JSON parameters that are pretty easy to think about, like country is US. Well, okay, that's pretty easy to evaluate. And then there's some that are a little bit more challenging, like this path parameter. So you'll see it's a nested JSON list. And on top of that, it's actually just a string. So it's string escaped JSON. So finding a way to kind of manipulate that data is going to be important for us as well. OK, so I kind of set up some motivation. I'm just going to show you just a quick video of using Raven. So here you can see sources. So I mentioned that you get data from devices, and you get also data. Is this readable? I don't know if this is readable. OK. So you get data from devices. You get data from servers. There's different kind of sources. API request source is one I'm going to show here. This is basically request headers on edge tiers. You know, you can kind of see all these different sources are hooked up, which makes it very convenient. You know, depending on what problem you are, you may want different sources of data. You can kind of also see that for the API request source, there's fields here. Now, as it turns out, you know, these are schema-less JSONs. It's not like there's a strict schema associated with the JSON. Having said that, there's often common fields. So we basically just sample the data and see what are the common fields. And then we populate this list to make it easier to work with the JSON without memorizing exactly what the structure is. And then you can kind of see these are fields that you sort of project. This is your select sort of statement in a SQL sense. The conditions here, you know, you kind of basically have the ability to narrow down. ESN is a string field, so the predicates are string related. Duration is a number, so you have numerical predicates. And you know, here I'm just saying, you know, I might be interested in situations where the duration is greater than 200 milliseconds. Another thing that you'll see down here, because I mentioned this isn't really a strict schema, you might have a sampled field. We're kind of suggesting fields, but maybe you know about another one you need here, and then you can just add it and add a criteria for it. You'll also see down here this sort of proprietary syntax, which is sort of how it's actually sent to the server to do the filtering. And if you want to manipulate it by hand, you can. Hopefully our tooling makes it so that you don't actually ever need to do that. Then you can kind of see, you know, we normally in prod, we encourage sampling for when you're just iterating so that we don't consume unnecessary resources. You can turn that on and off. So, you know, again, you know, whether you're hitting test data or prod data. And then lastly, you'll see you can either just run this query while you're looking at it, or you can run it for a longer period of time if you need it for a longer period of time. And I'll kind of go over some use cases for that. Also, we have the ability to persist an elastic search if you need. And then the last thing is, as you're iterating through this, it saves your query history. And you can also explicitly save things as recipes if you want to go back to them. OK, so you know, that's sort of the simple use case. Then you can submit a query. And then, again, this isn't like a query against the historical data. This is real-time data that's coming in on the fly. And then you can just kind of see some example of the data here. Over here, you know, this is 50 examples. There's also a button here where you can fetch more data, download, and other things that you might want to do. So this is just sort of simple, basic use case. We're going to build on this experience to do more complex things. You've probably seen query builder interfaces like this before, but this is sort of the basics, and then we're going to go forward from here. OK. So the next thing I'm going to do is I'm going to start with a motivating example that's very similar, which is about just looking at debug messages from client devices. see the type is debug. I'm going to get a message with a certain severity. There's info and error. And then basically, I'm just exploring this data. I'm like, I wonder what kind of data is in these debug messages to help me solve this problem. And you can see most of these are just strings. But then I see this one in here that is kind of interesting. This is a little bit of a contrived example where I just want to see how many debug messages are there counted. The ultimate goal of this is going to be to produce a plot for each SDK version. What's the total count of debug messages there are? So this is just, it's a little bit of a contrived example, but I want to show the power of the tool. So you'll notice that this particular data here, this is a message, which is, again, a string escaped piece of JSON. So even though it looks like JSON, it's actually a string. And so you're going to have to go and manipulate it and do any work you need with it. OK, so let's actually kind of show how I can get then SDK version. I want to pluck it out of that string and make it a top-level field in my JSON. We have an idea of that using something called mappers, which are just basically snippets of JavaScript to write a script where you basically transform an incoming JSON into an outgoing JSON. Very simple. It's a very simple but powerful idea. And you can run those on the client side, which means that this JSON just runs in your browser. That's basically while you're iterating and developing. And you can also run them on the server, where the data is manipulated in the server, and then you can chain that to other functionality we provide to do additional steps. So let's kind of go through an example of that. So now you'll notice that since I only care about SDK version, I've also done myself a favor by only getting things that contain the string SDK version from the server. Makes it a little bit easier. And I'm just going to prove that that actually data looks about right. And you can see now I'm only getting messages with SDK version in them. And so now I just need to add one of these mappers. So I'm going to add it on the client side. You can see here this function signature. The last two parameters really aren't that interesting. There's sort of specialized use cases where you want them. But basically, you just take the incoming JSON object, you return a JSON object after you've done some manipulation for it. And one way to do that is obviously to just iterate in line. Since this is a demo, I have saved one, and so I'm going to go get one that I've already saved. You can kind of see there's just like a list of ones that people have saved. You can see these are pretty well used. And then in the demo, I think I just do a little scrolling so you can see that a lot of people use this. And then I think that I'm going to go and pick the one that I want here. OK. And then what this is basically doing, right, oh, gosh. All right, let me fast forward a little bit. Yeah, OK, well, maybe a little bit more. OK, sorry. Seen this movie before? OK, all right, well. All right, just give me a second. I'll go back to the stage where it's at. And here we go. Sorry about that. OK, so you can see basically all it's doing, it's plucking out the message field. Since it's a JSON escape string, you have to parse it again. And then I pull out the SDK version and make it a top-level field. So pretty simple stuff. There's also some error handling here. And then, OK, so now I just want to go ahead and see some examples of this data with it applied. So just to kind of speed it up, I reloaded the page. And you can kind of see now in these examples that SDK version is now a top-level field. So it's just basic, very simply applying this JSON to the data. It's our way of extracting data from the field. So that's sort of the example of that. I also just kind of want to show you the save as a recipe feature. It's pretty simple, but basically, if you have a template like this that you want to use over and over again, I just want to highlight that one of the things that people like to do is save these recipes so that they can come back to them. And that's that. I just don't want to jinx myself by fast forwarding. OK, so now we have a JSON, and it has this top-level SDK field. So that's great. Could be useful if what you just want to do is get some collections of that. Maybe you store it in Elasticsearch. The fact that it's now a pretty easy to use field instead of a very complex field makes it a lot easier to use that. But what I want to do is then plug it into a tool called Atlas. That's another Netflix tool. That's also an open source tool. And what Atlas is basically, it's a time series plotting tool, but it allows you to basically plot numbers, but also tag those numbers with attributes so you can drill down on them. So to give you an example, let's say that you're counting requests per second. So the Atlas API sort of says, count a request for a particular device. And then that basically, you have a tag on your number. And the idea is basically, you can either show the overall RPS, or you can say, I just want it for this device. So it allows you to sort of drill down. And it has sort of three concepts. The one we're going to focus on in this demo is counters, but it also just has things like timers. They sort of support different operations. So for example, if you have a timer, you're probably interested in the 75th percentile. 75th percentile on a counter doesn't make any sense, right? So different APIs depending on what your data means. I apologize, this font might be a little bit too small, but it's the Atlas UI. And I don't know if you can squint just really closely up here. So this is basically an example of what I'm talking about, where there's sort of a name for an Atlas counter, and then this cluster basically, I'm basically saying I just care about the canary, right? What was the RPS on the canary for this thing? So I filtered by this tag called cluster. If I wanted to remove that, it would just show me the overall RPS. So I can kind of go back and forth between drill down and follow-up views with this. Okay, now that we've done that, how do we then turn these JSON records with an SDK in them into an Atlas counter that tells me how many of these were done for a particular SDK? So I'm going to start where I was before. I have exactly the same thing up here with this SDK version filter. And then one thing I'm going to change is, since it's Atlas data, it makes more sense, instead of just running till I leave, to run until I kill it, because you want a few minutes of data to plot. There's a warning there that says, don't overuse your server resources. So we have a freedom and responsibility culture at Netflix. So that's sort of how we trust that. But we also do audit it if people forget and do that. So here you'll notice I'm using the same JSON, but I'm also just doing it on the server side. And here I'm turning it to a counter, just like we said. So I want to count these. I'm going to give it a name so that I can, you have to give these counters a name. Pretty simple stuff. And then if you remember, we had a key in this JSON called SDK that we want to make into an Atlas tag. So I'm going to go ahead and do that. And that's really all you got to do. I'm just showing here, this isn't really that important, but if you want to explicitly control the scaling that you're allowing instead of letting the system do it, you can kind of limit your resources that way. I'm not going to use that feature. And then basically you submit a query. This is the part in the demo, if you've ever watched the cooking show where they put the unbaked pie into the oven and then it comes out fully baked. That's the next step I'm going to show, because it takes a few minutes to collect the data and then you have a plot that's interesting. So okay, so now we've run through the Atlas counter, and let me see if I can get this to, yeah, okay. So what I'm going to do is I'm going to go into my query history where I have this running Atlas counter, and I'm going to basically click on it. And you'll notice here, now it has a little graph, which is basically sort of just a very rough sketch of the data that Atlas has, with just a bunch of lines on it which represent the different SDKs. And then if you're interested, you can click through to this, to the more detailed Atlas UI. And what it'll show you then is, well, it's taking a second to load. Okay. And there you go. Okay, so now it basically has on here the same lines, but I know this is very small font, but these are basically all the different SDKs that are available, and then a line for each one. You can either get rid of the grouping, or what I'm going to do is just, this is a, let me see if I can get this to, I might say that this is a little bit hard to read, and okay, there's something weird going on in terms of, okay, great. Okay, so now I want to basically say, there's too many lines on this thing. I just want to drill down on a particular SDK. So I'm going to select the SDK I'm interested in, and then all the other lines disappear, and I can say, for this SDK, this is the count of these messages. So this is a little bit of a contrived example, but you can see where in different types of JSON logs, you might very well have some data, have something like this where plotting some data relatively quickly like this can provide a lot of interesting information. I should add, in addition to just being a tool for plotting data, so this is a numerical signal. There's a separate API I'm not going to go over here where you can then very quickly add an alert. for this signal, both on absolute values or on deviations from a trend. So in addition to just giving you a quick dashboard of whatever you're trying to look at, you can say, you know, this is important. I want to kind of create an alert on this if it varies in some way. And you can also do that quickly without any coding. OK, so that kind of shows you sort of a use case of just taking a relatively simple idea and basically working it through some tooling in ways that are pretty useful when you're debugging problems. Another sort of power use case I just want to mention just how it's implemented. This is relatively straightforward. So there's both an SDK and a command line interface that are associated with this. So the way that this browser application actually works is there's a pure JavaScript library that talks to the server, and then that server does orchestration with all the backend systems to make this thing work. We also then can use that pure JavaScript library in a Node.js application that just creates the command line interface tool. And that very quickly allows you to have both command line access and user interface access and make sure that they're both available at the same time. Just why do you ever want a command line interface? So you know, examples where people have really used it is, for example, in a Jenkins job. So you know, maybe you want to just grab some data and sanity check something as part of your Jenkins process. So you can just run this tool to grab some logs, look at them, make sure they make sense before you actually finish your Jenkins job. There's also the programmatic scripting use case. Somebody wants to just take a bunch of raw logs and do some machine learning on it or whatever, then they can just, you know, scoop up something and get some results and pipe them through some Python script, that kind of stuff. Just very high level, again, this talk isn't really about Atlas, but I just want to mention there's two kind of tools. So I mentioned that we also use Elasticsearch. Kibana is sort of a dashboard that runs on Elasticsearch, just a kind of high level difference between them. Elasticsearch stores every record, and that does allow you to do things like aggregation by just searching over all the records. It does tend to work very well when the dimensionality of your data is extremely large. So you know, if every value of a tag is different than every other value, then Kibana works pretty well. If you think about how Atlas works, what it basically is doing is creating a number for every tag value combination. And it's really optimized for the case where maybe you have 10 or 20 tags and they each have counts of 1 million or so. Then that's actually much more efficient than having, you know, 1 million documents a second that you have to crawl over to get the number, right? So different use cases. I think in general, for numerical stuff, Atlas tends to be more useful than Elasticsearch, but both are heavily used at Netflix depending on the use case. OK, so the last thing I want to talk about is actually the first step I mentioned in my example, which is, if you mention I had a bunch of customers, and I needed to figure out that what was in common between the ones that failed was a particular bad ASN number. So basically, what we're looking at is pretty high dimensionality data. So basically, there might be 50 categories of things you want to compare on. And what tends to come to mind first, people when I say, well, things in common, sounds like a quick machine learning clustering thing. So just, I don't know if you're familiar with machine learning, but there's sort of a concept called cursive dimensionality in machine learning, where if you have a bunch of dimensions, you're trying to kind of cluster based on distance. Well, if everything's 50 dimensional, it turns out that everything's kind of the same distance from everything else. And so those algorithms tend to break down in that situation. So what we actually found was much more useful for this problem is actually look dimension by dimension and just build some visualization exploration tools to kind of figure out what are the likely candidates and sort of zone in on the one that seems to be a culprit. Because most of the time, the fact that two things are in common may actually not be that interesting. I mean, usually one of these things is the cause of the bug, right? It's either an SDK version or the device you're using or something. I mean, sometimes it's a combination, but that's a little bit of a rarer situation. So I just kind of want to show you this capability. Again, it's available on Raven. There's some different reports. So this customer similarity analysis is one. And here, I'm just going to show you the interface for creating a job. And basically, you can paste in like a list of devices that are a problem. And then I just want to talk about what I'm showing here. So the fact that some things are in common by itself is not that interesting. So for example, if we found out that a lot of the users are in the US, well, OK, great. But a lot of Netflix traffic is in the US. So does that really mean anything or not? So the idea here is basically you need to have a baseline of what the other traffic, what just a random sample of data at Netflix looks like for this tool to make any sense. So that's the first part of it. The second part of it is, Well, typically when people select 50 IDs or whatever, they already know something about them. So let's say that every, you're debugging a problem on PS3 devices. Well, you don't want your baseline to be all traffic at Netflix rather than all PS3 traffic, because, what it's going to tell you is, hey, guess what? What's in common between all of them is they're all PS3 devices, which is something you already knew when you entered the data. So the idea basically here is you also kind of want to narrow down the baseline criteria based on what you know. So in this example, I'm just sort of saying, well, if I knew that everything was on ASN 11745, I should tell it that, because that traffic may look very different than other traffic at Netflix. So OK, I'm just kind of showing that feature. I'm not actually going to submit a job. These actually take, unlike the other tool, which was streaming data that comes in right away, you kind of have to go look this data up. This is more of a batch job. I'm just showing the different features. There's a submit and a cancel and whatnot. All right, and then I'm not actually going to submit this, so I'm going to go back up here to the tool and show you an example report. So I didn't actually generate a demo report. I'm just showing you this tool is really used by just picking one that somebody ran. I didn't actually show this, but there's actually hovers, so that if you're wondering what all these categories mean, you can kind of look it up. Basically, all right. Sorry, let me just fast forward to there. And OK. So basically, I just want to show, there's sort of 4 categories over here that help you look at what's in common. So here, I'm basically filtering by match percentage. There's also, you can filter by baseline percentage. And then there's sort of 2 that are sort of adjusted metrics for comparing how different you are from the baseline expectation based on your sample size. And so this is actually the statistically valid way to do this chi-squared thing at the right. It's called goodness of fit. There's actually a whole branch of statistics called contingency tables that has all sorts of different measurements for this. And then people will argue about which one makes most sense depending on your use case. I add that one. The interesting thing about chi-squared is it goes to 0 actually relatively fast, because the baseline is so much larger than a typical sample size that it tends to just be 0 very quickly if something isn't exactly matching. So I also have sort of an unscientific heuristic, which I'm calling f of x, that sort of just produces a not scientifically valid number that's smoothed a little bit that will tell you how in common your data is. And I think that basically in this example, I'm going to search here. And then, you kind of use the various combinations of fields to see something that's interesting. So you'll notice here that this is one where they both, one thing that's interesting, we're looking for things that are dissimilar. So a low chi-squared value is actually, good for this purpose. So this is an interesting one because your chi-squared value is low. You still have a pretty high heuristic. It's kind of interesting. And then, it just kind of shows you that maybe this UI name field is actually kind of an interesting one. Then you can kind of go and open this up, and you can kind of see the ones that don't match. So maybe, there's something about Akira that's buggy here, and you can kind of go and do some analysis of that data to figure out furthermore what's sort of the likely source of the bug based on what things are in common. So this sort of tooling is also pretty useful. We tend to use these tools in conjunction with each other to debug problems. But I just kind of want to give you an illustration of a typical way that we might solve a problem at Netflix. So those are kind of the tools I just wanted to show. So again, key things for us in terms of debugging and troubleshooting both during development and production is, fast log querying and filter at scale, ability to very quickly plot and manipulate that data without pushing code, and then comparison analysis to figure out where the likely source of the problems are. Because, at Netflix, you support so many devices and this kind of thing that's really quite important. So I don't know if that, you guys have any questions about that, or? Yeah.
The tool looks amazing, but I have a bit of a meta question. When do you start building such a tool?
Oh, OK. Yeah, that's a great question. This tool did sort of evolve, to be honest. So there were basically 2 pressures. One was from the customer care people they had sort of this customers in common type functionality that they were doing with just a Python script. And it was somewhat useful, but without visualization, it also wasn't that useful, right? So, it kind of gave some signal, but exploring the signal was actually quite difficult. And we have some UI visualization expertise on our team that they didn't, so we kind of inherited that. That's kind of how that happened. The generic Mantis feature, so there actually is a team that's responsible. I'm sorry, I used a word that I haven't introduced. Mantis is sort of the name of the streaming system that we're connected to. So that was a separate team. Their sort of secret capabilities are more in building highly distributed systems, this kind of thing. But they didn't really have a visualization experience. And what they built is a really awesome, highly powerful streaming system, something sort of like Storm or something like that. But the problem with it is you need to kind of write a lot of code to get started with it. So it's basically open up Eclipse, write a whole bunch of Java code. You have to know their APIs to kind of build this set of nodes together. And what they discovered is even though they had this awesome platform, it wasn't being used that well. And so this was another case where we had the visualization expertise. They had kind of started building a very simple version of this tool, and they realized that quickly the requirements were sort of beyond what they were willing to kind of invest in and support, even though it was sort of very important to the company. And so that sort of then became that learning sort of got absorbed into us. And then, just as bugs came up and people said, what would be great is if we could do this, that's how you kind of added in the Atlas feature and the alerting capabilities and all this other stuff. So I would say it was sort of evolution. I don't think we were geniuses who decided 5 years ago this is exactly what we need to build, but sort of how it happened.
What was so you inherit this Python set of scripts, I'm guessing. Was the design decision, hey, let's learn what we can learn out of this and then just start fresh? Or did you take that, wrap it in a web application? Like, what was the sort of the first step?
It was, I would say that what I did is I basically read the code. The issue with just using Python is the systems that we usually use at Netflix are Java-based. So to interact with most of the platform at Netflix, it's a lot easier to do it in a JVM language. So I ported some of it. I also added a lot of features that they didn't have access to because they weren't interacting with the Java platform API. So for example, ASN in particular is something that you can't get from Python. Like you need to be in Java to kind of look up our CDN cache and for metadata information. So we're able to add all that information in. But yeah, I mean, we definitely got a lot of knowledge from the Python scripts. And there's actually still some things in that Python script we need to add. So I mean, they had a customer care focus. So when, my current UI doesn't give you an ability to generate the list of interesting IDs from just a customer call ticket that listed the IDs. That's on the to-do list of something we want to add. But, so there's still things that we would probably pull in. But I think the main thing is, what they discovered is, this is really helping us, but with visualization, it would just take it light years further in terms of what we actually can do with it.
Can I add to something you said about your meta level question, I think? Maybe you were trying to ask, well, when does it make sense to invest in building things?
Exactly.
Right.
Like, when do you look at all these problems and you decide, yes, I'm going to build a tool for these use cases versus the rest of the problem?
Sure, I think a lot of it is scale, right? And to Seth's point, we didn't have this 5 years ago, and scale in many different dimensions. To sort of echo what Brennan said, there's of course scale of traffic, right? We've been growing and we went global earlier. This scale in terms of number of developers. We follow DevOps practices, so at some point it's not that a lot of developers, at least server-side developers, could write jobs on top of Mantis. It's like writing Spark streaming jobs, right? However, is that the best use of their time? So when you look at the amount of time spent in chasing down partner support issues, troubleshooting, these low-grade customer errors, you make the calculation of when does it become more efficient for us to automate those and genericize those. And the third thing for us in the real-time use case is, again, is scale, right? At our scale, time to detect and time to resolve just become really critical. A 30-minute outage versus a 10-minute outage is a big difference. And so that's very useful. That said, there are cases where that's not as important, and so Elasticsearch and Kibana gives us the ability to deal with dimensionality, and so we use that as well.
Other questions? Yep.
So as a follow-up to that question, like this has probably been a known problem. So how do you ensure that not many teams inside Netflix are trying to solve the same problems and build their own tools?
Well, I guess we kind of have this sort of motto, I guess, highly coupled, loosely aligned. So there is experimentation. In our case, I think that the way that things often work is there's a lot of server-side developers at Netflix. I would say that most client-side developers, though, aren't free to. Most of them are working on specific things like how to make the Netflix UI look awesome for customers. So I think we're one of the few teams that actually has the expertise to do this kind of visualization in the first place. So we're pretty natural that people come to us. I mean, we have had situations though where tools sort of naturally appeared to be on two teams, and I think that happens at any large company, and it's just a matter of figuring out how to solve that. I mean, I think there's an inherent trade-off, right? So if there's like a central coordinator, I mean, to think of it as a distributed system, central coordinator can be a bottleneck if they're shooting down every problem before the experiment begins. So I think that we're willing to have some overlap, but we're also willing, I mean, I think Sangeeta works a lot on making sure we prune that overlap as well so that we're not wasting time. So I think it's sort of a little bit of bottoms up and then somebody pruning the weeds, I guess.